Alright, so we're talking about the factors of 48, which when we multiply gives us 48, and when we add gives us 19. So again, when we do our verification, we discover that we have, remember all the signs are positive, so we have positive 16 and a positive 3. So when we put that together, we are going to have 4z squared plus 3z plus, we'll just arrange it with 16, so it's easier for us to factorize. So 16z plus 3z plus 12. Okay, so again we go by grouping the terms. So what is common here? We see 4z is common. We have z in the bracket plus 4z, plus 4, plus, what is common here is 3, bracket, z plus 4. So again we have another common term, which is z plus 4, and the last thing is 4z plus 3. So we have seen two examples of how when the coefficient of the first term in the trinomial is different from 1, and when it is with 1. So I guess at this level we have any questions? Any questions? And thumbs up to you if you are having it correct. Alright, let's walk on with the next thing. The next one is, how do we divide polynomials? How do we divide polynomials by, let me just quickly clean up this, division of polynomials. Division of polynomials. Division of polynomials. So we have two things we have to know on the division of polynomials. We have the factor theorem and the remainder theorem. From the word factor theorem and from the word remainder theorem, it can tell us a lot about it. Remainder theorem, definitely that when we divide a polynomial, right now I'm talking about the remainder theorem, when we divide a polynomial by a binomial, for sure, we will have a remainder. Just if I use a basic example, then if I divide 6, let's say by 5, I am going to have 6 goes into 5, or 5 goes into 6 one time, and then we have here 5. This gives us 1, and this is what we call the remainder. Alright, so we have the quotient, which is our answer, we have the divisor, and we have the dividend, then we have our remainder. So if I try to relate this with what we're talking about in polynomial, and if we say, let p of x be a polynomial, such that the binomial x plus a, where a is a real number, and of course a non-zero real number. Therefore, x plus a is equal to 0 implies x is equal to a. Hence, p of a should be equal to 0. This therefore takes us to what is known as the factor theorem. Of course, from the definition we got about factors, we said factors can divide evenly without any remainder. So therefore, there is nothing after dividing, we get a remainder. So when we divide that polynomial by a binomial, we should definitely get 0 as our final answer. But if the same case appears, we have x minus or plus a is equal to 0 implies x is equal to, we have, let's say, x minus a, so this gives us x minus a, this gives us plus a, such that p of a is equal to r. We have what we call the remainder theorem. I will do an example of both cases for us to understand what is happening. Alright, so if I take an example that you're asked to divide x squared minus 3x or x cubed minus 3x squared plus 4x, x cubed minus 3x squared plus 4x plus 2 plus 4x plus 2 plus 4x plus 2 by x minus 1 by x minus 1. So we are given a polynomial. Remember, already more than 2 terms we call it polynomial, or more than 3 terms we call it polynomial. Alright, so we are given a polynomial and we are asked to divide by this binomial. So now we can go by two methods, either using the direct method of solving the binomial and then replacing the values. And if our answer gives us 0, we talk about the factor theorem. And if it gives us a remainder, we talk about the remainder theorem. So we are going to have this, or we go by long division. So either way is correct. So therefore we are going to have x minus 1 is equal to 0, implies x is equal to, we have plus 1. So if I say let p of x be equal to x cubed minus 3x squared plus 4x plus 2. So we are going to have p of 1. Remember we said x is equal to a, where a is a real non-zero number. So we have